I hope everyone's having a great night. Thank you for joining me for this video. I am Mr. Ish. We're just looking here at a relatively straightforward geometry application here. Geometry, trigonometry, whatever you want to call it. We have a designation here such that we have a circle within which from the center we have two radii extending at a certain angle to either ends of that circumference aspect of the circle, and a chord is generated. The length of that chord is C, and we've abbreviated as C. The angle here for this theta must be less than pi, must be greater than 0. Why is that the case? Because if supposedly we have a certain angle here theta, we lose the ability to generate a chord other than a diameter. And I'm not talking about diameter. I wanted to have some sort of an angle so that you can have a triangle form. With the theta here of being pi, we lose the ability to generate a triangle. If theta here is actually equal to 0, theta here is equal to 0, we again lose the ability to generate a triangle. I want to look at those values between 0 and pi because you can demonstrate some form of a triangle. You can have an angle here such that you can have an acute, a right, or an obtuse. But we don't want to have a straight line, we don't want to have a 0 in terms of the angle. We have to find a formula for determining the length of that chord C. How do you go about doing something like that? It could be any representation here. You could have a center here with a radius here, a radius here. You could have a 90 degree, and then you're generating something like that. It could very well be an acute triangle here. A chord is C over here, angle here, R, radii, and you're looking at that chord over there. We should be able to come up with a single straightforward formula that will always help us determine the side C, dimension of that chord C. So long as you were given an angle and the radius, you could come up with a good computed result. If you take this triangle or any of those other triangles as I was showing you in these two scenarios I was pointing out, but let's just take the one we have before us. It looks something like this. We have the center right here, we have a radius, an angle, and side C. If we split this right down the middle, we have removed this theta, but we've generated two angles which are theta over 2. The original angle has been split into two halves. As you see, you've generated a 90 degree on both sides and you've generated two right triangles. This side C has been split into C over 2 and C over 2 half. If you look at supposedly this one right over here, this angle right here, with regards to this angle, you can use trigonometry. If you did sine of that angle, which is now half theta over 2, with regards to this angle, you're looking at an opposite or hypotenuse. It would be a C over 2 over R. And then you have sine theta over 2 is equal to C over 2R. You would just be calculating for C and you would have your formula 2R sine theta over 2. And this here would be a very legitimate formula for you to determine the length of a chord. Any chord that is generated for this condition over here. Any chord. So long as the angle is larger than 0 and it is less than pi. And I'm going to put the formula right here. C is equal to 2R sine theta over 2. And technically the question is completed. That's all there was to it. But just for a closure's sake, let's take a practical example. And let's look at this. We can verify indeed everything is good. We have an R angle here. Angle here happens to be pi over 2. Let's put everything over here. If you just use simple Pythagorean formula, a square plus b square is equal to r square. We have r square, and we have a hypotenuse square. You'll have a 2r square is equal to h square. And then here with regards to this h, we're calculating for h here because h here is synonymous with the c, right? The chord C. H is equal to square root of 2r square, which is r root 2. If we were to plug everything here in this formula with what we have here, utilizing r and the angle pi over 2, we should have something very much like that. And we will do so. C is equal to 2 times r times sine theta over 2 pi over 2 over 2. C is equal to 2r sine of pi over 4. We know pi over 4 in terms of a fraction is a 1 over root 2. Which is equal to 2r times 1 over root 2, which is equal to 2r over root 2, which if you were to rationalize it, you'll have a 2 root 2r over 2. You can cancel this out and you'll have a r root 2, exactly what you have over here and over here. We have shown you that this formula indeed is good for any chord which is generated in this manner for a triangle, whether there's a obtuse angle here, a right angle or an acute angle. The chord C generated in this situation would always be calculated by that formula right there, and it would be a good formula. You could keep it in the back of your mind, or you can just scrap it aside because you might have a better way of doing this. I was just showing you this way. This right here would be a very good way, a legitimate way, and that right there would be a formula for a chord C, 2r sine theta over 2. And that's it. Thank you for watching. Have a nice day.